So whenever you get to a word problem, the numbers aren't as nice because, like, when you're in a math class and we're doing practice questions, we often use nice numbers. Even that 3 to the 8, 64, 61, or whatever number, that would be considered a nice number. When you get to real life, actual figuring things out, it gets into decimals and it's not pretty. So here's a word problem. We've got a percentage of 0.8%. It starts in 2009 at 30,000. Estimate the population each year to the nearest 1,000. So we can say that term 1, 2009, we can make that our term 1. If something is growing, is term 2 going to be bigger or smaller than term 1? It's going to be bigger. And we've got that 0.8%. Okay? First of all, 0.8% as a decimal is 0.008. How am I going to mathematically show something grows by 0.8% or by multiplying by 0.0008? Now I'm going to show you two things on the calculator. The number one common thing that people do in this question is they would say, well, what is 0.8% of 30,000? So here's my, no, that's not my calculator. Here's my calculator. They go 30,000 and they multiply it by 0.008 and they get 240. And so if it's growing by 0.008, does it make sense that I could write, was it 280? 240. 240. Wow. 240. There we go. So that would be term 2. That shows that growth. But if I took term 2 and divided it by term 1, because this is going to make a geometric sequence, you're going to find out that you've actually multiplied by 1.008. And whenever something is growing, and you want to do the math behind it, you have to include that 1, because that 1 is the original amount plus the 0.008%. You actually probably do this if you ever bought something in Canada. There's a price tag on it. Then what's the sad thing that happens when you get to the register and actually have to pay for it?
Taxes.
Taxes! How much are our taxes right now? 12%. So you're like, oh, I can't wait to buy this calculus book. It's only $10. And then you go to the till and they go, and they add the 12%. You could figure out 12% and add it, or you could multiply by 1.12. 12% is 0.12, right? So if you're going to buy something, $30, and I times it by 1.12, this will be your final price all in one step. You'll pay $33.60. So whenever a percentage is added, your R value is going to be 1 point, and then whatever that percentage is as a decimal. So in our example here, we've got term 2. Now term 1 is 2009. Term 2 would be 2010. I could just keep doing this. 2011, 2012, 2013. That doesn't seem like too bad. I might actually, with a calculator, I might actually do this. And with a calculator, there are some tricks to do. All with Excel, you can do tons of stuff with Excel. But on my calculator here, I might take 30,000 was my starting point. And if I would have multiplied by 1.008, that would have got me my 30,204. If I just hit my multiplication button and do 1.008 again, it'll do 2011. And then if you've told it to do something, and you push enter again, so this is 2009, 2010, 2011, 2012, 2013. 30,971.6. But it says round to the nearest thousand. So it's actually, and I'll go back. I'll round it. I'll put the actual one rounded. If I can remember the number. 30972. But then in part A, it says estimate to the nearest thousand, so I round that up to 31,000. Okay? An estimate in this that you're predicting something probably doesn't make sense. Oh, I think there's going to be 30,971.5 people. It doesn't really make sense to use decimals here. And so the rounding is because we're doing an estimate anyways. But then on Nunavut's 50th birthday, I mean, I could just keep hitting enter on my calculator and hope I don't lose count. But it might be nice to actually use the formula here. So Tn, the general formula will be term 1, which is 30,000. The R value is 1.008 to the n minus 1. If 2049 what term will that be? And this is where sometimes the math gets a little bit tricky. Okay? If I do 2049 minus 9, you see that you, minus 2009, you see that you get 40. Okay? So, guess number 1 would be term 40. Okay, some of you are shaking your heads, because it's going to be wrong a little bit. But it seems like a good strategy, right? If I do 2049 minus 2009, I get 40, so I'm thinking maybe I should use term 40, and then use my formula. Okay? But sometimes when I'm doing real life problems like this, I want to double check. Okay? Is it going to be term 40? Well, check 2010. What happens if you do 2010 minus 2009? Do you get 1? Is 2010 term 1? No, it's term 2. Right? 2013 minus 2009, that gives me 4, but 2013 was term 5. This is confusing enough that the textbook actually has mistakes in answer keys in some places with these examples because they screwed up as well. It's that easy to make this mistake. So it's 40, but it's actually term 41. So when I go to my formula, I want to find term 41. Term 1 is 30,000, 1.008, 41 minus 40, no, 41, 10 minus 1, sorry, 41, I did, wow. Computer's really liking me today. There we go. No, wrong one. There we go. 41 minus 1, and I can go to my calculator and type this in. $30,000 times 1.008 to the exponent of 40, 41 minus 1, 41261 rounded to the nearest thousand would be 41,000. Sometimes when we round, and since it's a word problem, if there are units, and we're talking about people here, we should include our units. 41,000 people. Circle questions 10, 13, 14, and 15. And 15, I have a star beside because it is tricky. Maybe we'll even start tomorrow's class with it. Tomorrow, Monday.
It's a weekend.